Welcome back to the deep dive. Today we're doing things a little differently. We're going back in time, back to ancient Greece.
A little time travel for the deep dive.
Exactly. But we're not talking beaches and sunshine here. We're diving into the world of, well, geometry.
Sounds fun.
I know. Maybe not everyone's favorite subject, but trust me on this. We're talking about Euclid's Elements. This is a book that's shaped how we think for centuries.
It really has. Euclid's Elements, I mean, people might hear that and think, oh, another math book.
Yeah.
But it's so much more than that. It's really a masterpiece, a masterpiece of logic and reasoning.
So for those of us who, let's be honest, haven't really opened Elements since, well, school, what exactly is it?
Okay, so imagine this. You're building this massive cathedral, but with knowledge. Every brick, every bit of logic, that's what Euclid did. Elements is basically all these geometric propositions, postulates, proofs, all organized into, get this, 13 books.
13 books? Euclid was serious about this stuff.
Oh, absolutely. And each book, it's like a carefully placed brick, and the postulates, those are like the foundation holding the entire thing up.
Okay, so 13 books written around 300 BC, right? What makes this thing so groundbreaking that we're still talking about it today?
That's the amazing part. Even after all this time, Elements, it's still a cornerstone of mathematics, of logic, of how we think. See, Euclid, he gave us this idea of a deductive system. It's how we build knowledge, like from the ground up, with these really rigorous proofs.
Deductive system. Okay, break that down for me. How does that even work?
All right, so Euclid, he starts with these basic truths. We call them postulates and axioms, stuff that just makes sense. A straight line can be drawn between 2 points, stuff like that.
Yeah, seems pretty obvious.
Right. But that's the beauty. From these simple ideas, these almost undeniable truths, he builds and builds. So you get these more and more complex geometric concepts, all because each step is proven logically from the one before it.
So it's like this domino effect, but with knowledge.
Exactly. You got it. And this way of thinking, this rigorous, start with the basics, prove each step, it was revolutionary. And not just for geometry either. This idea, it went on to influence philosophy, science, law, even how we think today.
Whoa, hold on. So we're talking about this ancient Greek guy figuring out geometry, and he accidentally changes how everyone thinks about, everything.
Pretty much. Euclid showed us how powerful this kind of logical thinking could be. And it made people realize, hey, we can use this for way more than just shapes.
Okay, my mind is a little blown right now. So Euclid gives us this blueprint for critical thinking. But if we're picturing Elements like this amazing cathedral of knowledge, what are some of the big impressive parts?
Oh, there are so many. But one of the most famous, I mean, you've definitely heard of this one. It's the Pythagorean theorem.
Oh yeah, the square of the hypotenuse and all that. I have to admit, I memorized it, but never really got why it was such a big deal.
All right, so the Pythagorean theorem says that if you got a right-angled triangle, the square of the hypotenuse, which is that side opposite to the right angle, it's equal to the squares of the other two sides all added together. Simple to say, but incredibly important. It's not just about triangles, though, even though it sounds like that.
Right.
This theorem, it pops up everywhere. Architecture, engineering, physics, even making maps.
Wait, so something Euclid figured out thousands of years ago, it's still helping us build bridges and stuff today.
That's exactly it. It's how we understand distances and forces and how different shapes relate to each other. Honestly, once you start looking for it, the Pythagorean theorem is everywhere. But even that's not all of it. Elements, it goes way beyond. Euclid, he explored all sorts of geometric concepts, properties of circles, how to construct perfect pentagons, hexagons, all that.
Hold on, wait. Constructing shapes? With a ruler and compass, that kind of thing?
Euclid, he wasn't just here's what shapes are. He wanted to know how to make them, but only using those basic tools. It's like a puzzle, but with geometry.
That's kind of wild. I never thought about it like that. You know what? I'm starting to realize just how much this guy Euclid actually did. It's he figured out this whole universe, but for geometric knowledge.
He really did. And it didn't even stop at flat shapes. He was even looking into 3 dimensions. So pyramids, cones, spheres, solids, all that stuff still using the same logical steps.
Honestly, it blows my mind how he managed all that with what they had back then. So, okay, we've got this ancient Greek guy laying down the rules of geometry, influencing everything, even today. But on top of that, he's figuring out how to build these complex shapes with, a stick and a string, basically. And here's the thing. People have been studying this one book for centuries.
It's incredible, isn't it? It's not just some old book. Elements is alive. It still makes people curious. It still sparks debates, Even today, there are still questions in there, interpretations, stuff we're figuring out.
You know, honestly, what I find most interesting, it's not even just about the shapes themselves. It's
Right.
the thinking behind it all. That logical reasoning that Euclid was so into, that whole start with the basics, build your way up, that's useful no matter what, you know?
Totally. And here's another mind-blowing thing. Euclid, he didn't just use that system for shapes. He even took on some really abstract math ideas, like prime numbers.
Oh, that's interesting. Prime numbers, so those are the ones that are only divisible by one and themselves, right? What do shapes have to do with prime numbers?
You ready for this? Euclid, he actually came up with this super elegant proof about something we still study today. The fact that there are infinitely many prime numbers.
Wait, hold on. He proved that there's like an endless amount of prime numbers. How do you even start to prove something like that?
I know, right? It's kind of brain twister.
Oh,
So he starts by assuming the opposite. Like, okay, let's say there's only a limited number of primes, right? We've got a list. That's all of them.
okay.
Then he says, all right, what happens if we multiply all those primes on our list together? And then we add one.
So we get this like massive number, and it's one bigger than every prime multiplied together.
Right. And here's the genius part. This new number we just made, it has to be one of two things. Either it's a prime number itself, which means it wasn't on our complete list, or it's divisible by some other prime number that's also not on our list.
Because if it was divisible by one of the primes we already had, it wouldn't have that extra one at the end, right?
Exactly. It's like the theory self-destructs. And that's how Euclid showed that it doesn't matter how many prime numbers you find, there are always going to be more. Forever. Infinitely many.
That is incredible. It really makes you think, you know? Something figured out over 2,000 years ago can still feel completely mind-blowing. So we've talked about triangles and how to make shapes, even prime numbers. So we've got this ancient Greek mathematician laying out the rules of geometry, influencing everything from architecture to astronomy. And on top of that, he's figuring out how to build these complex shapes with just a compass and straight edge. What's even more amazing is that this one book has been studied and debated for thousands of years.
And that's what makes it so fascinating. It's not just a historical artifact. Elements is a living document that continues to spark curiosity and debate today. There are still unanswered questions and interpretations within its pages.
You know what's really interesting? It's not just about the shapes themselves, it's the thinking behind it. Euclid's emphasis on logical reasoning, on starting with basic truths and building up, that's a powerful tool to have in any era.
Absolutely. And what's remarkable is that Euclid didn't just use his system to explore shapes. He also tackled more abstract mathematical concepts, like the nature of prime numbers.
Now that sounds intriguing. We're talking about those numbers that are only divisible by one in themselves, right? What could shapes possibly have to do with prime numbers?
Prepare to have your mind blown. Euclid actually devised an elegant proof for a concept that's still studied today, the infinitude of prime numbers.
Hold on, let me get this straight. He proved that there is an infinite number of prime numbers. But how? Where do you even begin to prove something like that?
It's a bit of a head-scratcher, isn't it? He starts by assuming the opposite, that there's a finite, limited number of primes. Let's say we have a list of all of them. Now, Euclid says, let's multiply all those prime numbers together and add 1.
Okay, I'm following so far. We've got this massive number that's one bigger than the product of all our assumed primes.
Right. Now, here's the genius part. This new number we've created has to be either prime itself, meaning it wasn't on our complete list, or it's divisible by a prime number that's also not on our list. Either way, our initial assumption that we had a complete list of primes falls apart.
Because if it were divisible by any of the primes on our original list, there wouldn't be that extra one after the multiplication, right? It's like a self-destructing theory.
Exactly. And that's how Euclid demonstrated that no matter how many prime numbers you find, there will always be more out there, stretching out to infinity.
That's incredible. It's amazing to me that a concept discovered over 2,000 years ago can still feel so fresh and relevant. So we've talked about triangles, geometric constructions, even prime numbers. What's the one big takeaway you hope our listener walks away with today?
You know, for me, it's the enduring power of Euclid's ideas. Elements isn't just a dusty old textbook. It's a testament to the power of human curiosity and the timeless pursuit of knowledge. And while most of us may not be constructing perfect polygons in our daily lives,
The way Euclid approached problem solving, his dedication to building a system of understanding based on logic, and proved that's something we can all learn from.
absolutely, that's what makes Elements so much more than just a geometry book. It's a testament to the power of human reason. It teaches us that even complex ideas can be broken down and understood step by step, and that knowledge built on a solid foundation can endure for centuries.
It really makes you appreciate the elegance and the lasting impact of his work. So, after spending all this time with Euclid and his elements, what's one thing you'll take away from this deep dive? What resonated with you the most?
For me, it's the reminder that sometimes the most profound truths are hidden in plain sight. Those seemingly simple postulates Euclid started with, they became the building blocks for a whole universe of knowledge. It makes you wonder what simple truth we might be taking for granted today that could unlock even greater understanding in the future.
That's a really fascinating thought to leave us with. It's like Euclid is still challenging us to explore, to question, to never stop building our own cathedrals of knowledge.
Precisely, and that's the beauty of a deep dive like this. It's not just about what we've learned about Euclid, but what it inspires us to discover next.
So, to our listener, we leave you with this. What simple truths do you take for granted, and how could they shape your own exploration of the world? Until next time, keep diving.